Good day and welcome everyone. My name is Pete Will, and it's my pleasure to welcome you to this 6th webinar in a series of webinars organized in concert with the Esri Mining User Group, or the MUG as we like to refer to it as. This webinar is entitled ArcGIS Enterprise Architecture, Design and Administration Best Practices. During the webinar, we will discuss the methodology for developing a scalable architecture in deploying the ArcGIS suite of products. This webinar is being recorded, and a link to the recording will be posted in the next few days. And as a participant, you will receive an email to that link. And as is traditional in our webinars, we encourage you to submit your questions throughout the presentation in the GoToMeeting question dialog box. We will be answering as many of those questions as time permits. Any questions that we don't get to will be answered in a follow-up email. I will be your MC for the webinar. And to start, I'd like to introduce my guests that will be joining us today. As I mentioned earlier, my name is Pete Will. I'm based in Broomfield, Colorado, and I am Esri's Principal Account Manager to the mining industry. Also joining us today is Chris Franks. Chris is the Principal Committee Member for our Esri Mining User Group. Chris is with Freeport-McMoRan, and he's talking to us today from his office in Phoenix, Arizona. Presenting the key material today is Andrew and Ravi. They are both with our Esri Professional Services, and they are both on the Enterprise Implementation Services team. They are speaking to us today from their offices in Redland, California. Before we get started, I have asked Chris to say a few words as an introduction to the MUG and what the MUG is all about. Chris?
Thank you, Pete. Thanks again to everybody taking time out of your day to join our webinar. A brief history about the MUG. Our purpose is to gather business needs from all of our mining community members and then work in concert with Esri to drive our technology to match our business needs. And I think this particular webinar is going to be particularly insightful with the many changes that have come about in the Esri platform. As a group, we've been around for about 8 years. We have a LinkedIn site for all of our communication, and on the slide you can see that web address. Again, we're hosting these webinars and really working to facilitate the communication with our business community and drive business value. And when we're completed, as Pete indicated before, these webinars are going to be added to the online library, and again, you can see the address there. With that, I will turn it back over to Pete and look forward to hearing from all of our members. Thank you.
All right, great, Chris. Appreciate that. The material we'll be covering today was derived from conversations with the MUG members and was tailored to achieve really the following two objectives. One, provide an ArcGIS enterprise design and administration best practices, and also to answer the questions you may be having regarding your own enterprise architecture. So we have a lot of material to cover, and so I'm going to go ahead and turn it over to Andrew and Ravi to fully introduce themselves and then get started. Andrew, Ravi, over to you.
Thank you, Pete. My name is Andrew Sarkowitz. I've been with professional services for more than 16 years. Most of my time as a consultant, past 8 years or some as a practice lead. Ravi is our enterprise architecture lead. And today we'll talk about ArcGIS Enterprise with a focus on design, administration, best practices. Here's a high-level agenda, a very quick overview. What are design considerations? For example, how do we scale and separate workloads? What tools do we use here in professional services? How do we approach capacity planning for infrastructure? And then we'll discuss the value and importance of monitoring to support all the tasks in above agenda. So let's just dive in. What is Web GIS? At high level, Web GIS is just a pattern or architectural approach for implementing a modern GIS. Typically, it's powered by web services. So let's take a look at the high level. What does it mean? Well, traditionally, in the past, we were focusing on-premises deployments. Now, public cloud or private cloud is very popular. And the next level is software as a service. So we have several choices. There can also be a choice between customer managed and maybe a vendor managed. For example, Esri has Esri managed cloud services where we host solutions for our customers. And of course, there could be a hybrid solution as well. Portal is very important. It's a critical component of Web GIS. And now with the new capabilities, we can actually have many portals, which poses very interesting opportunities as well as challenges. This is very important for global companies like many in the audience. ArcGIS Enterprise is a key component of the ArcGIS platform and Web GIS. So we will really focus on that. Very quick overview. I know that most of you are familiar, but just to refresh. What are the key components of the ArcGIS Enterprise? Well, its portal starts with the portal, utilizing in the middle ArcGIS server, hosting server, and this hosting server is consuming data from data stores, relational or tile or spatial temporal. And to the left, you see a web adapter. It's just a proxy, helping us with connectivity and security. But really the takeaway from that is, we have portal, ArcGIS server, and data store. If we need to add additional capabilities, we can do this by adding these ArcGIS Enterprise server roles. There's one software component with multiple server roles. Let's just dive into specifics of design considerations. So, here's a busy slide, and I'm not expecting you to analyze all the icons. That's not the point. The point of the slide takeaway is that ArcGIS Enterprise depends on underlying infrastructure. This underlying infrastructure is indicated in a yellow font. So, for example, starts with certificates, load balancer, firewall, storage with immediate consistency, and databases. If any of these components are not available, this will impact ArcGIS Enterprise and in many cases creates the outage. So it's very important for us to architect the system for performance, high availability, and security. And we'll talk about these challenges more later. We start with designing a site. So we have choices. We used to have 3, now we just have 2 because clusters are deprecated. The recommended site design is ArcGIS server as a site design where we have one site with multiple nodes. It's the configuration on the left. Later I will explain why this is recommended and when it's required. In some cases, silo configuration might be still acceptable. We use it in cloud deployments or when we have a hardware load balancer where the focus is mainly on ArcGIS server and not just the entire Web GIS. But really to take away from this is if you have clusters, you need to be thinking how to migrate from that into a site. Because site will allow us to federate components, and below is the list of features that require the federation model. So takeaway is if you want to take advantage of this long list and growing, really the federation is a requirement. And as a consequence, a site design is required architecture. So once we have the site, if you're an administrator or an architect, what are the things that we need to focus on and how do we prioritize? You know, and I'm trying to answer directly several questions that we received. What is the priority? So for example, CPU. In many cases, our systems are CPU bound. So the fastest CPU, it will provide the highest return. If we have multiple services, RAM might, high number of services, RAM might be very important. And network stability and NAS is critical regardless of any type of deployment because many of the components are stored as shared components. So if we lose the connectivity, it's going to impact the ArcGIS Enterprise. It was especially true in the previous releases where ArcGIS Enterprise was hypersensitive to network stability. So, some of you might have experienced in the past that the site was reset because we lost connection to the config store. Several improvements have gone into our platform, but nevertheless, we're still relying on stable infrastructure. It's beyond the scope of this session to talk about the security, but of course it's a very important topic and it will impact a lot of decisions. What are the practical things that you can do as an administrator to help with your site stability? For example, avoid publishing high number of services. And I understand that this might not be always possible because you have business requirements to have a high number of services available. But perhaps we can implement some governance to reduce, if not eliminate, duplicate services. Also, it is not recommended to make any type of site administration during the business hours, for example, adding and removing nodes. And the final is, if you have high number of services and you keep the default recycle time, usually it's at midnight of your local time, it might be advisable to spread this maybe over different hours. Otherwise, at midnight, for a few minutes, a system might experience some performance degradation. So what other things we can do? If you are dealing with high number of services, it is critical that we identify unused services and reduce instances, min to zero if possible. It is easier said than done if we don't have tools. So if you are dealing with hundreds, maybe even thousands of services, where the popularity of the service changes daily, it is difficult to detect that and implement this. And for that reason, we developed ArcSoc Optimizer. It's a little bit more on that later. The next thing is tune slow services. This offers the very high return on investment because if we have slow services, they will consume a lot of resource in terms of CPU and memory. So you need to compensate this with infrastructure, which in turn there are licenses administration. So, to me is like sealing the windows or fixing the broken windows to reduce the heating or here in California cooling bill. I recommend that all of you look into this. For example, MXD% can quickly diagnose performance of your MXDs before you publish them. Also provide the best practices to the publishers on, for example, scale dependencies. And finally, even if we implement all these best practices, we need to monitor resources. The number of services can grow, there might be changes on your environment, so we certainly need to monitor these vital resources like CPU, memory, network latency. The good news is that Esri invests into development of ArcGIS Monitor. We're adding more features to make it easy for our community to monitor and address these challenges. If I ask anyone, do you require highly available solutions, secure, good performance? The answer is absolutely yes. That's what we want. But there is a cost element, so we need to balance our requirements with complexity and cost. So for example, we can just have on the left side simple backup and restore, and this may meet the requirements of non-mission critical application. And then we can go to the right spectrum where we have geographic redundancy with high availability, and you can just see even count the icons on this PowerPoint that the cost of solution in terms of the infrastructure, it's high number, a factor, maybe 4 or even 8, depending how we count this. But the takeaway from this is evaluate of your SLA requirements and make sure they are meeting your application requirements. Otherwise, it's not just the cost, but it's also complexity. So keep it simple. Oftentimes is the best defense to defend our system. Workload separation. So we have so many components, so many features, so many options. Oftentimes, we start with maybe one site and we have all of them on one machine. Usually we start visualization. I might include imagery. But as we grow, we need to separate these workloads. And I am not talking about technology yet. I'm not talking about GeoEvent server installed on a separate machine. This slide talks about user workload separation. Can we accomplish that? And if we have a high number of users, that makes it advisable to separate, we could implement that using this approach. So this slide shows us Esri platform, where on the upper left you see the geoanalytics has its own area, it's its own site. You can have multiple image servers depending on whether it's dynamic or analysis. The same with GP, because this geoprocessing might be very resource intensive. GIS server mapping visualization, that's standard. And finally, GeoEvent. And many of these components, they have their own data store, for example, relational or spatial temporal big data. So what is the practical advice? Well, we say ideally separate all these roles per site. But what if you have a small user load, just a few users? does it make sense to create multiple sites, which in turns requires a lot of infrastructure administration? In some cases, it might be okay to have a single site. However, here are the caveats. Be careful combining these roles. For example, hosting server and traditional server, because any component with the high resource utilization will impact the other one. Hosting, it's a lightweight technology. So if we combine with traditional, which has ArcSoc processes, they might be competing for the resources. The same with the image server. So avoid that. Never combine highly resource utilization components like geoanalytics or geoevent server with other roles, because it will be very challenging for us to troubleshoot. So you did the design, you followed the best practices, and you have adoption of your users, and you need to scale. We need to pretty much add capacity to the system. So let's start with the portal. Typically, portal it's a pass-through mechanism with a low utilization. However, we need to monitor this, because in some cases, for example, when we use insights or operation dashboard, the utilization will be higher. And if we are running out of capacity, the only way for us to scale it is vertically. What I mean by this, we just need to have a larger machine with more CPU and more cores. It could be a similar case with ArcGIS data store. It's important to understand that some components can scale only vertically. So we need to have a larger machine. Then others, like spatiotemporal, can scale horizontally. What I mean by this is that we can just add more machines, and it's easier. What are the tools and processes that we use here in professional services? The focus is really not on the tools, it's more on the methodology. I often get these questions, what are the tips and tricks to ensuring success of our ArcGIS Enterprise? And my answer is, there are no tricks, there's just work following the best practices. So we start with gathering requirements, designing, testing, and monitoring. And here in professional services, Esri, we use these tools because we developed them, we're familiar, and they've proven for, to be effective for us. But you can use other tools as long as they are meeting these requirements. And let's say that we have a new system. So on the top, there's a system designer, and the objective is to come up with architecture and capacity planning. We can use some rational models, analysis, interviews, and asking what is the projected number of users, or we can, when we prefer, to use empirical data from monitoring tools, parsing previous applications, and running some tests. So we offer the suite of tools, and these tools are available to you. Most of them are free. ArcGIS Monitor is a product, but talk to your account managers, there are a lot of discounts for EAP. Here's how you can get access to these tools. We'll talk a little bit about MXD PerfStat. How do we approach capacity planning? Okay, so I already mentioned that most of our solutions are CPU bound. So CPU is the #1 focus for us. If you have a large number of services, memory might be a bounding factor. Any type of I/O intensive operations like image services synchronization. Then we need to make sure that we have solid state disks. Network is always important. And virtualization. If you are using in-house virtualization, it's important that you communicate with your IT on the usage of your application. What do I mean by this? Well, IT monitors the usage of all VMs and it will reallocate resources as needed. But let's say that you have an application that tracks hurricanes. So if you are looking at average utilization outside of the hurricane season, it will be very low. And then during maybe July and August will be very high. So we need to communicate that perhaps the standby resources are required for our GIS solutions. Otherwise, these resources will be allocated, but it will be delayed. Oftentimes, these machines need to be moved from one cluster to another, and you will experience a performance degradation or perhaps even outages. And this is something that we've learned from other customers. If you want to budget plan for memory, that really varies. So for example, you can have a map service with 50 megs to 500 megs, but on the other hand, a GP tool could be 2 gigs. So it's very hard for us to provide just one number. You can use this table as a starting point to analyze how much memory you need. When we plan for capacity, it's actually mathematically, it's a very simple formula. As long as we have the user load, transactions per second, and the cost of transactions per CPU. So I do not expect you to take this formula and do your own capacity using spreadsheet, because there are lots of tools like System Designer and CPT and others. But I just want you to understand that these two primary input is transactions per second, user load. So if you need to do the network, it's the same concept, transactions per second, and we multiply by the size of the transactions to calculate required megabits per second or network latency. Again, all of it is available as part of System Designer. If you choose to use it, you will get some nice reports, Visio, and diagrams. So I mentioned that it's important for us to monitor the system, even if we design and follow best practices. The state of our enterprise always changes. We're adding services, we're adding users. It is important, and we have learned that the key to the success is to monitor end to end. So the next thing is there are many excellent tools that they do a phenomenal job of monitoring a lot of data. But oftentimes this, having just the data is not enough. We need information. We need to aggregate this information. And even then, this aggregated information might not be actionable. So my challenge to us, ArcGIS Monitor team, is to provide end-to-end and actionable information monitoring. Why do we need that? Because when I traveled as a consultant, I see these 3 typical cases, and they are really account for more than 95% of the cases. Number one is overloaded system. So even though you do the capacity given your current information, at some point there will be more users or perhaps more services. And if we go over the capacity, we will experience what this truck is experiencing. Unstable infrastructure, network, NAS, VMware. So if you're a GIS admin, how do you detect that? Oftentimes we just sit in a large room around the round table with all the admins, and we just discuss how is the network, how is the database. But this is not always the most effective. And you as a GIS admin, you need tools and also talking points to your IT and faster reaction time. So we need to empower you. Also, if something is misconfigured, we need tools to quickly identify what are the bottlenecks and remove them. ArcGIS Monitor is designed just to do that. It's not just for administrators to verify the health of the system, but also monitor the usage. Oftentimes it's important to understand underutilized resources and SLA. So if you have design that needs to be highly available and it's defined by the number of nines, so there might be 4 nines or 6 nines, we need tools to quantify that. Hopefully these monitoring tools will also lead to lower administration cost. Yeah, as I mentioned, they need to be effective. They need to quickly diagnose these typical challenges: unstable infrastructure, overloaded system, or a bottleneck. One point about monitoring tools, they cannot be intrusive, or they cannot be consuming production resources. We use ArcGIS Monitor to help Esri manage cloud services, and we monitor over 500 servers, so we are quite confident that it's a scalable solution. So when I say actionable information, and I do not want you to look at this as a how to use ArcGIS Monitor. It's more general guidance. We need to have actionable dashboards. So when something is marked as critical, behind that needs to be an action. So if we configure everything and it's critical, we can preview the charts to verify the impact of that. But after this, we need to go to the root cause. So here's the information from the logs, and you get specifics of what the problem is. The concept of the availability. So managers need to know just one number. How do I aggregate health of our system into just one number? And we use this concept of availability, which is based on critical alerts, and critical alerts are something that you can define based on uptime, performance, number of errors. So it will be your definition. Again, when I say end-to-end, I mean, if you recall the slides about ArcGIS Enterprise architecture, we need to cover database, ArcGIS infrastructure, or source of components. So what are the examples of that? We absolutely need to make sure that Esri platform is healthy. Server, portal, GeoEvent, GeoAnalytics, ArcSocs. The health needs to be broken down into components. So if Web GIS is not healthy, that it's not specific enough, that's not actionable. We need to have we need to identify a specific tier. You see on the right side, there's a relational data store, or maybe federated server, or hosted server, or maybe portal itself. So we need to zero down on the components. I talk about ArcSoc Optimizer. The way it is, the way it works, we analyze, because you have ArcGIS Monitor installed, so we have all the statistics about memory and ArcGIS server services. So we go back, for example, 30 days to analyze unused instances, and then we set them to predefined level. For example, you might say, if any service that has been used less than 10 seconds in past 30 days, set min to 0. This way, we have reduced the infrastructure requirements at some customers by a factor of 80%, especially when you have services they have seasonable usage, and you don't have a mechanism to clean it up. So identifying unused is only one step. The second step is identify hot services that maybe are underconfigured. So then we analyze the last day, and we adjust the instances to your predefined level. Because we have ArcGIS Monitor, we always know the high watermark usage of each services. There were questions about database. So whether you're using Oracle or SQL Server, or even data store, if your usage increases, you will have to make some adjustments to the data store. Number one adjustment is the number of connections. So behind a ArcGIS data store, there's a Postgres database, and like any database has limited number of connections. There's a default number of connections. So monitoring that is important, and then increasing before you run into this problem. I said many times importance of the infrastructure. All monitoring tools, they have that memory, CPU, whether it's a cloud. So here in managed services, we leverage cloud, Azure and Amazon. So ArcGIS Monitor has a lot of advanced features for that as well. It's important to monitor the usage. And usage is typically, as I mentioned, it's transactions per second or number of concurrent users. You recall that it was a key input into a capacity planning. So if we have these statistics, it helps us with projecting capacity needs for the future, but also correlating infrastructure utilization increase with the increased usage. So I always use the concept of victims and culprits, that high memory or CPU utilization or even performance is not a culprit, it's a victim of something else. And number one factor is the usage spike. The good news is that it's very easy to detect if you have the right tools. Oftentimes it helps for us to see the map of where the users are coming from. There might be marketing value or also capacity planning. If you're interested, you can go to the website. It's a get started, very easy way to install. If you want to test first, there's a demo site, so you can go there and just see what are the feature, whether they meet your requirements. So that's what I have for today. We have plenty of time for for question. Pete?
All right. Thanks, Andrew, very much for that. A lot of material. We did wind up a little bit earlier. We do have a few questions, but I'm sure we'll be getting more in that we can answer as people have an opportunity to digest everything they're hearing here. And if anyone does have questions, we're still open to answering those. So I'm just going to answer these as they came in and kind of just ask them as they're presented to me here. First, can ArcGIS Server be federated with ArcGIS Online? Did you get that, Andrew?
Yeah, this is Ravi.
Okay, Ravi.
Yeah, as of today, no, it is not possible to federate ArcGIS Online, but you can register your services from your internal ArcGIS Server implementation in ArcGIS Online and utilize it in your applications.
Okay, great. Thank you. This next question is one that I encounter quite a bit throughout the mining industry, and it has to do with latency and bandwidth. With a wide area network, with WAN performance, do you need for this, let's see if I can read this properly. What WAN performance do you need for the silo operation to work, i.e. latency and bandwidth? This question comes from Africa, where they have very high latency and narrow bandwidth.
Right. Latency plays a very important role, obviously, in providing the best performance. One thing, though, to consider is for web applications, it doesn't play a big role as such. It's mainly of concern when there is desktop utilization across low latency network utilization, low latency bandwidths, right? With reference to web applications, as long as the requests are small and the right size images are passed through with the proper setup on the ArcGIS server, we could achieve acceptable results even with low latency bandwidth.
Yes, so to elaborate on this, of course there are limits. Yes, so if somebody has a dial-up, this actually might not return even one packet. But I want to elaborate on what Ravi said is there's a big difference between Web GIS protocols and desktop protocols, mainly related to the number of round trips. So ArcMap is very chatty. So if you use ArcMap as a client, it requires good bandwidth because there are so many round trips. But if you publish this MXD as a map service and consume that, it actually might work. But there might be some situations like geoanalytics or maybe image server when the size of the transaction, the response is very large. I recommend that you talk to an architect and use these. They will use these formulas that I mentioned. What is the transport time as a function of transaction size and the bandwidth? I don't know if you recall the slide, but there's a mathematical way to determine what will be the latency of that. And then you need to talk to your users and ask them, what is the accepted latency? Most web users will not accept anything over 6 seconds. So I hope that these guidelines are sufficient for you to quantify and make decisions how to approach that.
Okay, thanks. Another question, what provides the best performance overall, i.e. processing, stability, a set of VMs or a set of physical boxes?
All
right.
Rodney?
Yes. Obviously, physical boxes would provide just taking apple-to-apple comparisons. Physical boxes would have better performance, but physical boxes come with their own constraints of when you need to scale up or scale down. It becomes tedious. So, just looking at performance, physical boxes provides the best performance over VM. But as I said, it comes with its own caveat. VM virtualization technology comes up with its own benefits. We need to keep that in mind.
Okay, thank you. Another question, back to CPU. Does CPU speed have a significant impact on performance? You may have gone over that a little bit, but could you elaborate on that?
So you broke a little bit, Pete. Can you repeat that, please?
Yeah, going to CPU speed, does CPU speed have a significant impact on performance?
Yes, it does. With respect to a CPU that was purchased in, say, for example, 2005, had a different level of processing capabilities. But a CPU that's purchased today has some other higher performance capabilities. So obviously the CPU rate, which is called the spec rate, which is measured using spec and rate, has impact on the performance.
Okay, thank you. Another question that came in is what is a good setup for image server as it relates to processing and RAM requirements?
Yeah, the answer is going to be, it depends, right? It depends on the type of images that you're processing, what's the kind of processing you're looking for.
Yeah, so if I may jump in, we have two options to a rational analysis using our models, but even better, empirical. We always recommend to use empirical analysis if we have a test case, if we have something that we can just quickly profile. This will offer us the higher level of accuracy and confidence. The second option is using these rational models and trying to estimate the usage of memory and CPU based on complexity in operations. But with the tools like system test and others, or even simply standing up a test service and quickly using tools like Fiddler or other profilers, we can answer these questions with higher accuracy.
Okay. Just to continue on, we have quite a few of them, but I'll try to get to as many as I can. And you may have touched on this a little bit. What is that best practice for creating a federated and a high availability environment?
Yeah, there are various principles to follow for this. For instance, right, Andrew touched upon it. Go for site configuration so that you can add more machines from server level. Go with a highly available configuration for portal so that you can make sure that you have high availability. Come up with a good disaster recovery plan so that you can make the system available even during a disaster situation. Yeah.
Okay. Now this is a little bit of a.
You might.
Andrew.
Oh, you remember my slide on the spectrum of options. So again, the best practices, technical might be use redundancy and geographic redundancy and as much redundancy as possible. But it's very important for us to keep the cost and complexity in mind and making sure that we're meeting the application requirements. So I think that what I have seen in the past is that some of these discussions are done by architects who might not have a full information, and they will always follow the best practices of being conservative. So all this redundancy, including the geographic. But we need to tie it up to the requirements, because with the complexity, the risks are growing. So, for example, we have out-of-the-box Portal HA, and that is that's an excellent solution, but it requires a lot of attention and focus and good configuration to make it work properly. Otherwise, this HA configuration might result in lower availability of the overall system because it's not configured correctly. So I want this to be, please internalize that, because complexity actually can have a negative impact on the overall system if it's not done and managed correctly.
Okay, great. Now this question may be a little bit out of topic, but I'm going to go ahead and present this one. The question is highlighting the integration with big data in the distributed architecture. Can you touch on that a little bit?
Yeah. Big data is multifaceted, right? Esri, we have a solution called to manage big data, right? To receive and process big data, which uses GeoEnt as the tool and the solution for it. And there's a software solution called a spatiotemporal big data store, which is a part of the ArcGIS data store, which is used for storing the data. And to analyze these data, we have the solution GeoAnalytics. So with respect to architecting these, we should follow the principles that Andrew spoke about during the presentation, bringing in workload separation and separation of responsibility, and architect them or design them in such a way that they go in different sites. We should never combine multiple server roles, especially when big data is involved, as it's going to be both memory and processor intensive.
Okay, and I think we'll wrap up with this question. What security, firewall, protocol, port management aspects need to be considered? And keeping in mind allowing mobile connectivity. A short version of that, again, what security, firewall, and protocol, port management aspects need to be considered?
Yeah, GIS has grown into a full-fledged IT solution, right? So anything that we follow for a typical IT solution should be followed for GIS, Web GIS implementations too. For instance, the web adapter, that's the component that comes with, is a component that you can use as reverse proxies or as a load distribution agent in your DMZ, and going through the logical architecture part of it, right? That would be your presentation tier, where you can have it in your DMZ. But all the other components, like your portal, your ArcGIS server, your databases, your ArcGIS data store, it's better to be kept in a trusted zone. And obviously, it requires multiple ports and to be opened up from the web adapter in the DMZ to the application and the data tier solutions living in the trusted zone, like port 6443, 7443, and things like that. It's all well documented in our ArcGIS Enterprise help document. But at a high level, yeah, at least these two zones, your web adapter in your DMZ with all the other, your presentation layer in the DMZ, which is your web adapter, and all the other application and data tier in your trusted zone is a good security model to follow. Along with that, we have other options of securing for authentication and authorization, right? ArcGIS Enterprise comes up with various levels of integration with your Active Directory, either directly hooking up to your Active Directory or using a federation service, right? Like using SAML. So these are various things that you can consider for mobile. Obviously, if you have a secured service that you need to access, and if it is federated to SAML, you can use the same authentication you would use and get your application and services authenticated using that credentials.
Okay, thanks, Ravi. And actually, I'm going to have one last question, and this one may be a little obvious, but I'm going to go ahead and ask it. As a GIS professional, when should I involve my IT group when implementing ArcGIS Enterprise?
I'd say from beginning to end. Let me put it this way, right? If you define the phases of your implementation as plan, design, configure, and operate, you would involve them during the planning stage. You would involve them during your design phase. You would involve them during your configure phase. You would involve them during your operation phase.
And if I can add to this, thank you, Ravi, is to facilitate effective communication between GIS administrators and IT, we need to have a good talking points. So to involve them in a not just qualitative, but quantitative discussions. For example, I am estimating that I will need 160 gigs of RAM, then I will have these IOPS, then I will have that much CPU, that the usage will be seasonal, that the peaks will be 3 times a day. You know, so the more information the IT has, the better they can act. The same with the database, the same with the network. It's not sufficient just to bring them in and say we will be designing and deploying new solution.
So the more planning, the better. So excellent. Thank you very much. Well, we're coming up on the top of the hour, so we should wrap things up. We've presented a lot of material today. So remember, this presentation has been recorded, and you'll be able to refer to it after we're done here. I want to sincerely thank everyone who has attended today's webinar. And if you could, there is a short survey that will pop up right after the webinar ends. And we would really appreciate your feedback on that. We use your suggestions and feedback when designing our future webinars. So please, your input is very important. We're looking forward to seeing you at our next webinar, which we will be scheduling and letting you know about shortly. And lastly, if you have any follow-up questions, you're always welcome to contact me directly, and it's Peter Will at pwill@esri.com. Thanks, everybody.